Hello everyone. Welcome to the solution of LeetCode problem 209 named minimum size subarray sum. In this problem, we are given an integer of positive array and we are given a positive integer. Now we have to return the minimum length of the subarray whose sum is greater than or equal to target. And if there is no such subarray, we have to return 0 instead. Now here, a subarray is a contiguous non-empty subsequence of elements in an array. Now, let's consider the first example. The array contains 6 elements, which is 2, 3, 1, 2, 4, 3, and the target is 7. So here, for this subarray 4 and 3, the summation is greater than or equal to 7. So the length is 2. Similarly, in the example 2, the target is 4 and the array contains 3 elements, which is 1, 4, and 4. So here for any of the 4, and if we take any of the 4 as a subarray, the length will be 1 and the summation will be equal to 4, which is greater than or equal to the target. Now here, in the third example, for this array, their summation can be equal to or greater than the target, so we have to return 0. Now, the constraint are the value of the target can be in between 1 to 10 to the power 9 and the array length can be in between 1 to 10 to the power 5 and each of the array element can be in between 1 to 10 to the power 4. I hope you understood the problem statement. Now let's move on to the algorithm. Now to solve this problem, we will use the 2 pointers mechanism along with the sliding window technique. And in the sliding window technique, we use one of the window and we will shift the window to the right side until we reach the answer. Now here, let us take 2 pointers. One is left and another is right, and both of them are pointing to the first element. So let's take this subarray. Now our subarray length is 1. So here, the summation will be 1. Now 1 is definitely less than 7. So it cannot be a desired subsequence or the subarray. Now we have to shift our right pointer to this. That means we have to expand our window size. So here, the summation will be 2 plus 3, which is 5. Now 5 is definitely less than 7. So we cannot consider this as one of the subarray. So we have to increase our right pointer to this and it will become 5 plus 1, which will be 6. Now 6 is definitely less than 7. So again, we have to shift our right pointer here and we have to expand our window and it will become 6 plus 2, that means 8. Now 8 is greater than 7. So we can make or consider this window as one of the desired output. So here the length of this window is 4. Now we have two choice. Either we can expand this window into the left side or we can shrink the window into this side. Now, which will be the better? Here, the optimal is we have to shift our left pointer into this position or shrink the window, because if we expand the window into the right side, into this position, the summation will again become greater than or equal to the target and the length will be much greater than the previous one. So in this problem, we are trying to basically minimize the length. So we have to try to shrink the left pointer or shrink the window. Now our left pointer is pointing to this and our window is this. And if we shift the left pointer, we have to subtract 2 from the sum. So it will become 8 minus 2, which will be 6. Now 6 is definitely less than 7. So we have to shift our right pointer to this position. Now it will become 6 plus 4, which will be 10. So 10 is greater than 7. That means we have found one of the window here. So we have to try whether we can find another minimum length subarray such that their summation is greater than 7. So here we have to shift our left pointer here, and by shifting the left pointer, we have to subtract 3 from the sum. So it will become 10 minus 3, which will be 7. Now, let's erase it. And the length or the window is this. So again, we have to check whether we can find any of the minimum array. So we have to simply shift our left pointer to this. Now our window is this, and subtract 1 from 7. So it will become 6, which is the summation of 2 and 4. Now 6 is less than 7. So we have to expand our window and add 3 to the summation, which will become 9. Now 9 is greater than 7. So we have to shift our left pointer, and right pointer is here. So our window is this. So we have to subtract 2 from 9, and it will become 7. And the length of this window is 2. So now from this window size, we can see that the minimum is 2. And the answer for this problem is 2. So here the overall time complexity of this problem is big O of n. And this is how we will take one of the window and shift or increase the window size or decrease the window size and shift the window into the right side until we get the result. And this is how we're going to solve this problem. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named minimum subarray length, which has integer k and a vector as a parameter. Now we are taking sum of the variable, sum, answer, I and j. Initially, both I and j pointer initialized with 0. Now here, we are running this loop until the j pointers become out of bound. Now in each iteration, we are adding the j value of a to the sum, and by repetitively we are checking whether our sum is greater than or equal to k or not. If our sum is greater than or equal to k, that means we have to check whether we can find any minimum length subarray where the sum is greater than or equal to k. So here we have to subtract the ith value from the sum and upgrade the answer with the minimum of answer and length of the subarray, which is j minus I plus 1. Finally, we have to increase the value of I. After that, we have to shift our j pointer. And finally, if our answer is equal to int max, that means we cannot find any of the answer or any of the subarray by using this 2 pointers mechanism. So we have to return 0. Otherwise, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.